Hello students, I am solving chapter number 1, Matter in Our Surrounding for class 9 science. And in this video, I am going to solve NCERT questions which are present at the end of this chapter, and that is on page number 12. So let's start with the questions. I have completed the explanation of this whole chapter and even the questions which are given in between the chapter. Go through my channel, watch my all the videos, and if you like my videos, share my videos with your friends. Now, the question number 1 in NCERT exercise is convert the following temperature to Celsius scale. Nothing but it is degree Celsius. So here the temperature is given in Kelvin and we have to convert it into degree Celsius. So let's start with the answer. To convert temperature from Kelvin to Celsius, that is degree Celsius, use the formula. So what is the formula for this? Formula is we want degree Celsius, therefore degree Celsius is equals to Kelvin minus 273. Kelvin means it is a standard scale. So whatever temperature is given to us, that is in the Kelvin. So from that temperature, we have to minus 273. Remember this. And when you minus, subtract, you will get the answer. And that answer should be in degree Celsius. So we'll start with first one, that is 293 Kelvin. So take the formula, that is degree Celsius is equals to, in place of K, substitute 293 minus 273. So 293 minus 273. 3 minus 3 will be 0, 9 minus 7 is 2 and 2 minus 2 will be 0. So the answer is 20. Therefore, we should write 20 and the unit is in degree Celsius. Second one is 470 Kelvin. So formula degree Celsius is equals to 470 minus 273. So 470 minus 273. 10 minus 3 will be 7. So carry 1. Then 17 minus 8. Here 7 is nothing but carry 1. So it will become 17. 17 minus 8 will be, it will be 9. So write down here 9. Carry 1. Then 4 minus 3 will be 1. So the answer is 197. So write down it is 197 degrees Celsius. So here we have converted our temperature from Kelvin to degree Celsius. So remember, they have given 293 Kelvin. It is nothing but is equals to 20 degrees Celsius. So it is in Kelvin, it is in degree Celsius. For second question, they have given 470 Kelvin and we have converted into degree Celsius, then it will become 197 degrees Celsius. So these both the values are same. So this is the answer for question number 1. Now we will see question number 2. Convert the following temperature to the degree Celsius. So here, actually it is not the correct question. Convert the following temperature to, here it should be Kelvin. So I'll write it here, Kelvin, not degree Celsius. Convert the following temperature to Kelvin. And here the questions they have given, temperature is given in degree Celsius. See here, 25 degrees Celsius, 373 degrees Celsius. We have to convert this into Kelvin. That is nothing but capital K. So the formula for this is here, to convert temperature from degree Celsius to Kelvin, formula is Kelvin is equals to degree Celsius plus 273. So whatever value is given in degree Celsius, in this we have to add 273. And whatever answer we'll get, that will be in Kelvin. Very simple. So take the first number, 25 degrees Celsius. Formula is Kelvin is equals to degree Celsius is 25 plus 273. So 273 and add this 25. What we'll get? 5 plus 3 is 8. 7 plus 2 is 9 and here it will be 2. So 298 will get. So write down the answer 298 and now the unit is Kelvin. Next one is 470 K. So Kelvin is equals to, here what I have to do, let me clear it. It is not 373 actually. Wait a minute, I have made a small mistake. The question is here 373. So I'll write here, sorry for the correction, 373 degrees Celsius. This is the question which is given. And now take this 373 plus 273. So here 373 plus 273. 3 will be 6, 7 is 14, 1 4 write down here, 1 will be carrying here, 3 plus 3 will be 6. So the answer is 646. So write down 646 Kelvin. So here remember 25 degrees Celsius and 298 Kelvin, both are same. One is in degree Celsius and the other one is in Kelvin. Same way in the second one, 373 degrees Celsius or 646 Kelvin, both are same. One is in Kelvin and one is in degree Celsius. So this is the answer for question number 2. Now we'll move with the next question. Now the next question, question number 2, give reason for the following observations. So here we have some of the observation. Here we have 2. This is A and this is B. So first we will solve A. Naphthalene ball disappear with time without leaving any solid. So remember the observation is what? Naphthalene balls. The naphthalene ball will be used to kept in a cloth cupboard and all. So those naphthalene ball disappear with time without leaving any solid. This is a naphthalene ball which we use in our day-to-day life to keep it in a cupboard so that cockroach will not come into the cupboard. So answer is, let me keep it properly. So now I have adjusted. Actually, second, this A and B has got mixed. Now I have properly adjusted. So let's start it once again. So naphthalene balls disappear with time without leaving any solid. So answer is naphthalene balls sublimes. What is sublimes? Sublimes is nothing but sublimation. Sublimation means what? Sublimation is conversion of solid into directly gases without undergoing any liquid state. That is called as sublimation. So these naphthalene balls, the white color balls which we kept in cupboard, that undergo the sublimation. They convert from solid to gas, which means they change directly from solid to gas without becoming liquid. The vapors mix with air, so the solid gradually disappears without leaving any residue. If this is a naphthalene ball, if it now it is a solid, when it converts slowly into gaseous state, the size of this naphthalene will be go on decreasing. And when it is converting into gaseous state, these all the gases will get mixed into the air. When the air moves apart, these all the particles move on the other side. Then again the next naphthalene particles convert into gases. Again it comes into the air, and this process continues till this naphthalene ball get disappear. So remember the main method which is responsible for this is sublimation, conversion of solid to gas. The next B is we can get the smell of perfume sitting several meters away. Answer: perfume vapors diffuse into the air. Diffusion is the movement of particles from a region of higher concentration to lower concentration. So what is perfume? Perfume is one of the substance which is or made up of some substance which are volatile. So when perfume is spread, the vapors of perfume will get mixed into the air. And because these are in gaseous state, the diffusion takes place. Diffusion means what? Movement of particles from higher concentration to lower. For example, imagine if this is the room, and in this corner if there is a perfume bottle. Imagine, and if you spray here perfume, these all the perfume particles will get mixed into this air. And here the perfume is in high concentration, but here there is no perfume, so I can say it is low concentration. So easily these perfume particles will move from high concentration to low concentration. So see here, since gas particles move very fast, the smell spreads quickly through the air and reaches our nose even from a distance. So I hope you understood the answer of this. So now the next question. Now we will see question number 3. Arrange the following substances in increasing order of forces of attraction between the particles. Water, sugar, oxygen. So what is the question here? They have given the substances like water, sugar and oxygen, and we have to arrange this depending on the force of attraction, and that too in increasing order. Means first there should be a substance has low force of attraction in between the particles, then high, and then the highest. So answer: to arrange substances in increasing order of force of attraction between the particles, remember some points. Now, I have already explained this in while explaining the chapter. You can go through my all the videos and watch all the videos so that it will be easy to answer this question. If you see solid, the arrangement of particle is packed. See here, particles in solid will arrange very close to each other. Why they are arranged close to each other in solid? Because particles have a strong force of attraction. This particle is attracting the other particle toward itself. This particle is attracting the other particle toward itself. And because of the strong force of attraction between both, they come close and remain stick to each other, and that's why we will get this type of arrangement in solid. In case of liquid, if you see, the particles are little bit far from each other. So you can arrange like this. So this is the arrangement of liquids. So if you see here, particles are little bit far. They have space. Means they have attraction between the particles. If you see the attraction compared to solid, the attraction is less. And that's why liquids can flow. And therefore liquids comes under fluid. So here force of attractions are less. In solid, force of attractions are high. What about gases? If you tell me to draw the arrangement of particles in gases, then the gas particles will be far from each other. Why they are far from each other? Because the particles have very less forces of attraction between them, and that's why the space between the particle is very high. Attraction is, I can write, least. And because of the attraction only, we can see this type of arrangement of particles. So see here, as I told, gas is weakest force, or I have written least force. Liquids, moderate force. Moderate means in between solids and gases. So moderate force. And solids have strongest force, that is high. Based on this information, now we can classify. Oxygen they have given. Oxygen comes under gases. So therefore, gases comes here, least force. Water comes under liquid. Where is liquid? Liquid comes here. Sugar comes under solid comes here. So which has highest forces are in sugar, then comes water, and then comes oxygen. Therefore, final order, that is nothing but increasing force of attraction. I should write first oxygen, it has least attraction, then increased will be in water, it has moderate attraction, then it will be more increased in sugar, that has highest or strongest forces. So this is the order, and remember this sign which show the increasing order. One more sign is there, this it is showing decreasing order, less than. This is called more than and this is called less than sign. So this we can use here to show the order, that is increasing order of forces. I hope you will understand this. Now we'll move with the next question 4. What is the physical state of water at? So physical state means what? Matter has three states, that is solid, liquid and gases. So same way for water we have three states. So for solid, water is called ice. For liquid, it is called water itself. And for gases, it is called steam or water vapor. So now based on this, we have to tell, depending on the temperature, the water will be in which physical state. So see here, to determine the physical state of water, remember some points. First point, freezing point is 0 degrees Celsius. So whenever the temperature of water is 0 degrees Celsius, water starts freezing, means it converts into solid. Boiling point is 100 degrees Celsius. Whenever the temperature of water reaches to 100 degrees Celsius, water starts boiling, means it converts from liquid to gases. So this we have to remember. For 0 degrees Celsius, it converts from liquid to solid, and at 100 degrees Celsius, it converts from liquid to gases. Now we'll start our answer. First one, they have asked 25 degrees Celsius. Now see here, 25 degrees Celsius, it is the temperature which is above 0. It is greater than 0. If I write here 0, it is greater than 0. And this temperature is less than 100. Here, it is less than 100. So at 0 degrees Celsius, it will be solid. At 100 degrees Celsius, it will be gaseous. So it is in between, means it will be in liquid state, and therefore I have written water is in the liquid state. And one more thing, remember, 25 degrees Celsius, it is nothing but a room temperature or a normal temperature, day-to-day life temperature. And at this temperature, everybody has seen water will be in liquid state. Now the next one, 0 degrees Celsius. So just now I told 0 degrees Celsius is the freezing point, means at 0 degrees Celsius, water starts freezing. So see the answer, water can be both solid, that is ice, and liquid state, that is water. Why both? Because at 0 degrees Celsius, water started freezing. Means some water is converted into ice and some water is still converting, and therefore we have water in both the state, solid as well as liquid. Then third one is 100 degrees Celsius. Again same, very simple. 100 is the boiling point. So at 100, water started boiling. Means just now started means some water is still in liquid state and some water is converted into gaseous state. Therefore, water can be both liquid as well as gaseous state. This is the answer for question number 4. Now we'll move to the next question. Now we will see sixth question. Give two reasons to justify. So we have to give two reasons for this. First question or the first statement, water at room temperature is liquid. So here the reason is liquid, it has a definite volume but no fixed shape. So if you see water at room temperature, it has a definite volume. If you take water in a glass, say it is 10 ml, and if you transfer this water in a container like this, still it will be 10 ml. Volume will not change. But if you see the shape will change. Here it took the shape of glass, but here it is taking the shape of this container. So it has definite volume but no fixed shape. It takes the shape of container. Second, its particle can move or flow easily, showing fluidity. So whenever we transfer water from glass to container, it can be easily flow. You have seen it will easily flow. And also if you throw this water on the ground, then also you maybe have seen water can easily flow. And because of these 2 points, we can say that water at room temperature it is in liquid state. The B statement is an iron almirah is a solid at room temperature. Almirah is nothing but the iron cupboard which will be used to keep the things into the cupboard. So the answer is, if you see almirah, it has a definite shape, fixed shape and definite volume. Second one, its particles are tightly packed. Like water, ion almirah cannot flow. So the particles are tightly packed. There is no intermolecular space into this ion particle and only vibrate in the fixed position. So it is rigid. What will be rigid? Rigid is the property of solid. Definite shape and definite volume, it is the property of solid, and therefore an iron almirah is a solid at room temperature. So this is the answer for question number 6. Now the next question, question number 7. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? See here, we have taken ice which is at 273 Kelvin, even we have taken water at 273 Kelvin. If you compare the cooling property, ice cooling property is more effective than water. Answer, ice at 273, it is nothing but in terms of degree Celsius, it is 0 degree Celsius. So ice at 273 Kelvin or 0 degree Celsius is more effective in cooling than water at the same temperature. First reason is ice needs absorb extra heat from the surrounding to change its state from solid to liquid. Remember, if you take ice into the pan and if it keep it on the table, to convert this ice into water, it requires heat or energy. So it absorbs the surrounding heat and convert this ice into water state. This heat is called latent heat of fusion. So whatever heat is absorbed from the surrounding, it is called as what? Latent heat. And what is fusion? Fusion is nothing but melting. So solid we are converting into water, means you are melting. So the heat required for this process is called latent heat of fusion. During this process, ice takes heat from the surrounding without increasing its temperature, resulting in more cooling effect. So for this melting process, ice will take the surrounding heat. See here, it will take the surrounding heat for melting process. So it will not increase the temperature, but whatever energy it is absorbing, that all energy it will use to melt this ice. And because it is absorbing the surrounding heat, all surrounding area becomes cool. And that's why ice will show more cooling effect compared to water. Very simple answer. Next, the question number 8. What produces more severe burns, boiling water or steam? Same question like earlier, but little bit different. So what is the question here? Question is, if we take boiling water and steam, which will burn or which will burn more? So the answer is, steam produces more severe burns than boiling water. Steam means what? Steam means water vapor. Steam means water vapor. How the water vapor will form? When we take water into the container, which is in liquid state, and when we heat it, at 100 degrees Celsius, water starts boiling. Once it starts boiling, it converts into gases. But if you see the temperature into the thermometer, it will not change. You are heating. See here, we are continuously supplying heat. But that heat will not be shown into the thermometer by increasing the temperature. Then where heat is going? Heat is taken by this water and converted into steam. So these steam particles, water vapor particle have more heat. See here, these have more heat because whatever heat we are supplying, that all heat will be used by this water to convert into steam. So steam have more heat compared to the water present in the beaker. And that's why this steam will burn severe burn. It shows severe burn. Now see, answer. Steam at 100 degrees Celsius contains extra heat called latent heat of vaporization. When steam comes in contact with skin, it condenses into water and releases this extra heat. So if after conversion of water to steam, if the steam comes in contact with the skin, now what is skin? Skin means what? Temperature is low. less temperature. When the steam comes in contact with the skin, because of less temperature, it again converts into liquid. The state changes from gaseous to liquid. And when this conversion takes place, it liberates all the heat which it has absorbed for the conversion. And this heat will be hidden inside the water vapors. Next, this release of additional heat causes more damage to the skin compared to boiling water at the same temperature, because boiling water is not having any extra heat, but steam has extra heat because it is converted from liquid to gaseous. So that's why this is the reason for this question number 8. I hope you will understand. Read it carefully. You will understand the meaning of this each and every sentence. Now we'll see next question. Now the next is last question, that is question number 9. Name A, B, C, D, E and F in the following diagram. Following diagram showing changes in its state. So this is the diagram which is given. Let me do it a little bit bigger. Okay, now I hope it is clear diagram. So see here, this is solid converted into liquid, liquid converted into gases. So here there are some alphabets like A, B, C and D. So we have to tell the methods which shows conversion of solid to liquid, liquid to gas, gas to liquid and liquid to solid. You can see the arrows. Arrows are showing the direction. And then there is one more here, E, conversion of solid to gas, and F, conversion of gas to solid. So very simple. Start with the answer. Answer A is what? A is melting, nothing but fusion. We are converting solid to liquid, like ice to water. Then B is conversion of liquid to gas, that is water to water vapor. It is called vaporization. Liquid to gas, and this will be done on heating. Remember, we have to heat. To convert solid to liquid also we have to heat. To convert liquid to gas we have to heat. Next is C. C is, you can see the arrow, it is conversion of gas to liquid. So whenever you convert gas to liquid, you have to cool it, decrease the temperature. So whenever you cool, the process is called as condensation. Vapors, especially water vapors, if you cool, again they will convert it into water. That is the example for this. The next is D, which is here, conversion of liquid to solid. Means you can convert water to ice. And how we can convert? By keeping in fridge. So fridge, if you are keeping, means what? Temperature is less. So here also we have to require to cool. So on cooling, we can convert liquid to solid. The process is called as freezing or solidification. Conversion of solid means solidification. Then comes E, that is conversion of solid to directly gas. It is, here we can give the example of camphor. You take camphor and heat it, directly becomes gas. And here also we have to heat, and the process is called as sublimation, because solid is directly converted into gases without undergoing liquid state. So it is called as sublimation. On heating, solid converts gas without undergoing liquid state. Next is F, which is here. You see the arrow this side. So conversion of gas to solid means reverse. If here we require heating, then reverse means here we require cooling. And that's why we can write gas directly converted into solid on cooling. And here the process is called as deposition. Remember, the process is deposition. It is the reverse of sublimation. So this is the answer for question number 9. I hope you will understand the answer of these all the questions. So here we complete the solution of NCERT exercise question. So with this I have completed everything, explanation, chapters in between, questions in between the chapters, and as well as NCERT exercise questions from this chapter number 1, matter in our surrounding. After this I will start with the second chapter, that is matter around us pure. So if you like my videos, share my videos with your friends, and if you are getting little bit also help from these all the videos, then please consider subscribing my channel. Thank you so much.